Hello, my name is Sandy Boris Shigota, and today I will present you my research on the application of artificial intelligence in the problem of COVID-19 spread prediction. Research that I worked on with my colleagues Nikola Angelic, Ivan Lorenzin, Dr. Vedran Mezljak, and Dr. Zlatan Car, all employed at the Faculty of Engineering in Rijeka. So, as we all know, COVID-19 is a great threat. We are all familiar with it at this point. And we know that actions need to be applied to combat it, to lower the spread rate of COVID-19. If these actions are too aggressive, they can cause other issues. Due to that, government officials and health officials need to have information on how the number of cases is going to act in the future. And this is something that can be done through the epidemiological curves of the virus spread. These curves are complex to model due to a large number of influencing factors such as healthcare quality, population density, and others. So the question arises if if standard modeling methods are insufficient, can artificial intelligence modeling be used in modeling of epidemiological curves? Here we can see an example of epidemiology curves for Croatia in the period from 22nd of January to 22nd of October. The number of active cases, which is the epidemiology curve here, is defined by taking the number of confirmed cases and then subtracting the number of recovered and deceased patients. So the data used in this research is obtained from the COVID-19 data repository published by Center for System Science and Engineering at Johns Hopkins University. The dataset contains a time series of confirmed, deceased, and recovered cases in various locations globally. To be utilized in this research, the dataset has been transformed into a regression dataset by taking the latitude and longitude of a given location and the time elapsed from the start of the dataset, 22nd of January, as inputs, while the number of confirmed, deceased, and recovered cases are used as outputs. Two methods have been applied so far: an artificial neural network multilayer perceptron regressor, which uses a single neuron in the output layer and a number of hidden layers to regress the value, and genetic programming, which generates a number of possible candidate solutions, and then through recombining them and mutating them, attempts to achieve a higher quality solution through the number of generations. Both of these methods can only regress a single value, so 3 different models for recovered, deceased, and confirmed cases are developed, and then their outputs are used per this equation to calculate the epidemiology curve. Both algorithms have a k-fold cross-validation applied to them, where k equals 10, in order to determine the stability of the solution, and the hyperparameters for both methods have been optimized using grid search hyperparameter search. The results for both methods have been evaluated using the coefficient of determination r². For the latest results, both methods achieve high scores in excess of 0.99 for all 3 prediction goals. The results of part of the research that was done before have been published or accepted for publication in journals that are indexed in World of Science and Scopus. And on the image we can see how the predicted data follows the real data very well. With that, I would like to thank you for your attention, and I hope you found this interesting.